moving from left to right and then from right to left. How do we read and interpret the EM spectrum? Okay, we're going to talk about that, and we're also going to talk about Roy G. Biv, or we're going to talk about RMI ICUXG. All right, this is a way to help students or anyone basically interpret the EM spectrum, and it's talking about the electromagnetic spectrum and light waves and so forth. All right, so come on, let's go. All right, first thing we're going to do is I'm just going to draw the EM spectrum, just like a replica, to get you to understand what it looks like, okay? So here I am, I'm just going to draw like a rectangular shape. And remember, I'm not here for my artistic work, okay? Just the information. All right, here we go. So first thing we're going to do is we're going to label our actual spectrum. First thing I'm going to do, I'm going to draw like a little face right inside here, like that. Okay, give him a little smile or something. All right, and then what we're going to do, I'm going to put C here. That means visible. That's the visible part of my spectrum. That's the only part that I know that I can see. Okay, all right, to my left or to my right, to your left and to your right, you're blinded. You can't see any of these actual waves, okay? Why? Because they're either too small and you can't see them, okay? So let's understand what's going on. So to my right, I'm gonna have IC, which is UXG. To our left, we're gonna put this RMI. And what does that simply mean for me? I'm going to go ahead, I'm going to kind of section these off so you can see what's going on. All right? So from left, I'm going to put L, R. From left to right, I want you to say with me, RMI, C, which means C, which is the visible spectrum, UXG. So RMI, ICUXG, which means radio, microwave, infrared, visible light or visible spectrum, ultraviolet, X-ray, and gamma ray. Okay, that's the basic structure for the actual EM spectrum. So what I'm going to do now, I'm going to section them off by putting in my wave. So my wave is going to look something like that. What we're saying is from left to right, then the wavelength gets shorter. Okay? And then one more thing happens. From left to right, my wavelength gets shorter, but my frequency increases. So I'm going to put F right here for frequency. Frequency increases. All right, let's go back over that. From left to right, my wavelength decreases. My wavelength decreases, meaning that it gets shorter, but my what? My frequency increases. I put shorter, but I'm going to go ahead and put decrease here so you understand. So wavelength decreases, but frequency increases. What does that mean? So let me use my hand here for a second. If I put my fingers up like this, if they're spaced out, that simply means my wavelength are longer. Length, long, length, long. Frequency basically does what? Increases also, because it takes longer for me to move from here to here to here to here. But if I do like that and close my fingers, that means what? It takes a shorter distance, a shorter time, so to speak, a shorter time for me to reach from this finger to this finger to this finger. So let's recap. When my fingers are closest together, my frequency increases, but the what? The distance or the time it takes for me to get there basically is shorter. So my wavelength is going to decrease, but my frequency increase. Does that make sense? So remember, RMICUXG. Okay? So now we know it's radio wave, microwave, infrared, visible spectrum, ultraviolet, X-ray, and gamma ray. Now let's go the other way, okay? We did left to right, so let's do right to left. So I'm going to put right to left. From right to left, my frequency decreases and my wavelength increase. So I'm going to put WL for wavelength increase. So I'm going to put an arrow going up. Increases, but my frequency does what? Decreases. So they're like reciprocal. So when I'm going from right to left, my frequency decreases, and then when I'm going from right to left, my wavelength increases. And that's all we got today for learning the electromagnetic spectrum. We call that the EMS, electromagnetic spectrum. All right? So this is Andrew Guy. I just want to tell you thanks for joining us, and my job to make science a little bit more practical. Take care. Have a good day.